Hey everyone, and welcome. Today we're going to tackle a classic Java concept that honestly trips a lot of people up, string reversal. We're going to break down exactly what's happening under the hood, step by step, and make it super visual. You know that feeling when you're staring at a line of code, trying to actually picture how the letters in a string flip around? Yeah, if that's you, you are definitely not alone. But stick with me, because we're about to make this whole thing crystal clear. All right, let's dive right in. First up, the string reversal mystery. And you might be thinking, why this topic? Well, you'd be surprised. This one little operation is actually a gateway to understanding some of Java's biggest, most important ideas. Yeah, this isn't just some abstract puzzle to solve for fun. It's a really practical skill. You'll see it pop up in coding challenges and for sure in technical interviews. But more than that, getting a handle on this builds your understanding of core Java principles. And trust me, mastering it, it's a huge confidence booster. Okay, now for the plot twist. Here's the thing. You can't just swap the letters in a Java string. There's this one really important rule in the language that just gets right in the way. So, that brings up the big question, right? Why can't we just reverse a string in place? I mean, if we have a string, why can't we just shuffle its characters around? Well, the answer comes down to one single, powerful, and yes, sometimes tricky concept in Java. And that concept is immutability. Basically, think of it like this. Once a string object is created in Java, it's like it's been set in stone. You cannot change it. You can't alter it, you can't add to it, you can't remove any of its characters. It is, for all intents and purposes, unchangeable, locked down. And that rule has a really important consequence. If we want to get our reversed string olach, we literally can't touch the original hello. Instead, we have to build a completely new string from scratch, somewhere else in memory, to hold those reversed characters. Okay, so now that we get the why we can't just change the original string, let's look at our first solution. I like to call this one the char character dance, because it involves some pretty clever footwork with pointers. So here's the dance. Step 1, we take our unchangeable string and break it into a character array, which we can change. Step 2, we set up 2 pointers, one at the very start and one at the very end. Then the magic happens. We swap the characters at those 2 pointers, and then we move both pointers one step closer to the middle. We just keep doing that. Swap, move, until they finally meet or cross. And for the grand finale, we take that modified array and build a brand new string from it. Done. So that totally works, right? And honestly, it's a fantastic way to really understand how algorithms work under the hood. It absolutely gets the job done. But there's a much, much easier way. In a real-world project, you'd probably use a more direct and, frankly, more elegant solution that's already built right into Java. So what is this better way? Well, it's time to introduce the real hero of our story, the StringBuilder class. This tool was literally designed to solve this exact problem of string immutability. Just look at that. That's it. That one line does everything we just did in our 4-step dance. It's beautiful, right? We create a new StringBuilder object, which, unlike a string, is immutable, meaning it's meant to be changed. Then we just call its built-in reverse method, and finally convert it back into a regular string with 2string. So clean, so clear, and so powerful. So let's actually put these 2 methods side by side. Look, the char array method, it's awesome for learning. If you're in a coding interview, showing you can do this from scratch is a huge plus. But for your day-to-day practical code, the StringBuilder method is going to be your best friend. It's just so much easier to read and understand what's going on. The intent is perfectly clear. Okay, so now you've got 2 powerful tools in your toolkit, the manual way and the built-in way. But let's talk about the big picture. Where are you actually going to use this skill out in the wild? Honestly, this logic is everywhere once you start looking. The classic example is checking for a palindrome. You know, a word like race car, that's the same forwards and backwards. How do you check that in code? You reverse it. You'll also see it in data processing, where maybe data comes in backwards. And of course, it's a total staple in all sorts of algorithmic puzzles and those technical interviews we keep talking about. All right, so now it's your turn. I have a challenge for you. Open up your favorite code editor and actually implement both of these methods. Get your hands dirty. Feel the difference for yourself. One teaches you the raw mechanics, and the other shows you the elegance of using the right tool for the job. So, which one do you think is more powerful? Which one are you going to reach for next time you face this problem?